Hey folks, 3.4 is the last section in the identity chapter, chapter 3, and these are labeled other identities. Doesn't mean that they're any less important. Sine A and cosine B, that product idea, and shows up a lot in application problems. And I think I'm going to keep it simple because I think that you've done plenty of other identities working on those. So all I want you to do in this section is you're going to prove all of these formulas here. And so you have 8 formulas to prove, I think. Or no, it's only 6 formulas because they already do 3, 3, 7, and 3, 4, 1 in the book. And then there's one application problem where you're actually going to use this identity. Alright, so we're going to try to prove 338, and what we're going to do is we're just going to start off on the right hand side. It's just like the book suggested, so you start off with just without the 1/2. You do sine of a plus b minus sine of a minus b, and this was back from 3.2. So these are the sum and difference identities. So with the first one, if I expand the first, so that's from 312, we have sine A cosine B plus cosine A sine B. The second part now, this is a difference formula, so the second part we're going to expand and we're going to use 316. So from 316, and it's going to be minus parentheses sine A cosine B minus cosine A sine B. If I distribute this minus and think about what the like terms are, do you see that sine A cosine B, they actually cancel out right here? So this sine A and this sine A cosine B cancel out, and I'm left with plus or positive cosine A sine B, and then it's plus cosine A sine B, so that's equal to 2 cosine A sine B. Alright, notice that in this case, because we're trying to get cosine A sine B, if I just put that 1/2, see this 2, I don't want this 2 in that. If I just bring that over to the kind of the other side, which I guess when you're proving an identity you just want to start with one side. I could have just started with that 1/2 initially, and why don't we just do that to make it official? So the whole time, what if we just put this 1/2 right out front? That's not going to affect anything, right? So then we're going to do this 1/2 here, put a 1/2 here. That's even nicer, right? And then we're going to carry this 1/2 right here. Alright, and then we're just going to have this 1/2 right here. So that's then equal to straight up cosine A sine B. Okay, so we proved that little identity there, QED. So the other identities included here, we're going from a sum to a product. And so to derive these, and they mention this in the book, and they actually derive 3, 4, 3, but we're going to say, and this is a little algebra trickery, so we have let x equal 1/2 A plus B. And do I expect you to just pull this out of your hat? No. This is stuff that they've been thinking about for a really long time. Thousands of years, in fact. So don't worry about it. You can use this fact when you're proving all of these, okay? So once you have these two pieces of information, well, if I add these together, x plus y, the book doesn't really show y, but we would have 1/2 A plus B, that's the first term, right? Plus 1/2, because this is y, A minus B, this is substitution. This is 1/2 A plus 1/2 B plus 1/2 A minus 1/2 B. These cancel out, and you're left with 1/2 plus 1/2, 2 over 2, that's just A. So I know that x plus y equals A, and a similar thing would happen, and you can try it on your own, x minus y is going to equal B. So if we wanted to derive, let's just derive 3, 4, 1. So we have sine of A plus sine of B. From substitution and from this information, if I put in x plus y and x minus y, then I have sine of x plus y plus sine because b is equal to x minus y. Now thinking about the above formulas, the ones that we proved before, and I'm not going to bring them up, but 3.37 to 3.40, so these, we can find something that looks similar to that. So if you look back up there, which is it's on the same page in your book, where is it that you have something plus and plus sine of the two angles plus? Well, that's 337. So if we use 337 and expand that, from here I can actually get a 1/2 by doing a little math magic. So I can put a 2 out here, right? I can also just put a 1/2 over here. Do you see that 2 times 1/2 would just give me 1? So I'm not introducing a 1/2, I'm really just accounting for it right here. So now I have that x plus y plus sine of x minus y. Okay, so as you can see, this right here, the 1/2 sine x plus y plus sine x minus y, is equivalent to 337. Your angles are x and y instead of a and b. So we can rewrite that as 2 sine x cosine y. So once again, check 337. That's equivalent to that. We know that x is equal to 1/2 a plus b. So we're going to substitute that in. And we also know that y is equal to 1/2 a minus b. So we will substitute that in. So once we do that, we've actually completed our little proof. And we're finished with proving 3, 4, 1. I'm going to give you a little hint for number 9. Setting it up, the first thing, we want to show that this is our end result here, right? And so I know that P of t is equal to V of t times I of t. I heard that some of you thought that these V's look like square roots, but those are actually my V's, because if I don't have the little squiggly wiggly, it would look like a square root. So, or it would look like a U. So now, just from substitution, notice that V of t is equal to this. So I'm going to substitute. So we've got V sub m cosine, that's omega t plus theta. And let's just do some fun color coding. And I of t is equal to this. So we're going to say I sub m cosine omega t plus phi. So now what I'm going to do is I'm just clean this up, because I actually have a product here of cosines, and I wanted to show you that. So you got V sub m, I sub m, and now you've got a cosine of wt plus theta, and then you have cosine of wt plus phi. All right, so this right here is a product, and so you can use 339 to expand this product to a sum. See how the end result has a sum in here? So that could be a little thing, a heads up. You're going to have this V sub m, I sub m, and that is right here and here, okay? And now the hardest part is to recognize, in this case, this W or omega t is A, the whole thing is A. So omega t plus theta is A, and in this case, omega t plus phi is B. All right, so see if you can expand that. If you still have questions, let me know. This is the end of this lesson. We're not getting too in-depth in this. Don't get too bogged down by reading the examples. They're really, really technical and kind of an advanced math. We don't need to get into that just yet. If you become a math major and want to study math, then you can go back to it. Have a nice day.